Hello everyone, welcome to Homework Help. If you find the video is useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine the critical points for the function, determine whether the critical point is a local maximum or minimum, and sketch the graph of the function. So we are given the function f at x equals 1 over 3x cubed minus 9x plus 2. Now critical points are points at which the derivative is either equal to 0 or is undefined. So the first step is to find the derivative of this function f at x. So the first step is prime of f at x equals, now this is a polynomial function. So let's start with the first term. So in the first term 1 over 3 is the coefficient, so it will stay as it is. And for x cube, we can use the power rule. So we can move the exponent 3 to the front. So we get 3 times x and we subtract 1 from 3. Then minus, in the second term, 9 is the coefficient, so it will stay as it is. And the derivative of x is 1. And 2 is a constant, so its derivative is equal to 0. Now we can simplify this expression. So prime of f at x. So 1 over 3 times 3 is equal to 1. So we won't write 1 as a coefficient. So we get x squared minus 9. So 9 times 1 is 9 and the 0 goes away. Now the prime of f at x is a polynomial function. So there is no x value that will make it undefined. So we just have to find the x values that make the prime of f at x equal to 0. So for that we'll sub in the left side as 0 and we have to solve this equation. So we have to isolate x. So the first step is to add 9 to both sides. So the 9's on the right side will cancel each other out. So we get 9 equals x squared. And now we can apply square root to both sides. So the square root and the square on the x will get cancelled out, and square root of 9 is 3. So plus minus 3 equals x. So we get two critical numbers. So the first critical number is x equals negative 3 and the other one is x equals positive 3. Now we can find the critical points. So for that we'll have to sub in these x values one by one in the given function. So let's start with x as negative 3. So f at negative 3 equals over 3, then negative 3 cubed minus 9 times negative 3 plus 2. Now we can simplify this expression. So negative 3 cubed is negative 27 and 1 over 3 times negative 27 is negative 9 and negative 9 times negative 3 is positive 27 and then plus 2. So we get f negative 3 equals positive 20. So the critical point is negative 3, 20. So this is the first critical point for this function. Now for the second critical point, we should sub in x as 3 in the given function. So f at 3 equals 1 over 3 times 3 cubed minus 9 times 3 plus 2. So we get f at 3. So 3 cubed is 27 and 1 over 3 times 27 is 9 minus 9 times 3 which is 27 and then plus 2. So now we can combine these terms. So we get negative 16. So the second critical point is 3 comma negative 16. So these are the two critical points for this function. Now we have to determine whether the critical points are local maximum or minimum. So for that we'll use the first derivative test, and if the first derivative is greater than 0 in an interval, that means the function is increasing, and if the first derivative is less than 0, that means the function is decreasing. So we'll use the number line method. So now we can show the critical numbers. So the critical numbers are -3 and +3, and these numbers divide the number line into 3 parts. And we have to use a test value in each of these 3 parts. So on the left side of -3, we can use the test value -4. Between -3 and 3, we can use the test value 0. And to the right side of 3, we can use the test value 4. So we have to sub in these test values one by one in the derivative of the function. And if the derivative value is greater than 0, that means the function is increasing in that interval. And if the derivative value is less than 0, that means the function is decreasing in that interval. So we'll use the expression for prime of f at x. So for x equals -4, we do prime of f at -4 equals, so we get -4 squared minus 9. So we have to use the prime of f at x equation. So it's this one. So now we can simplify this expression. So prime of f at -4 equals 16 minus 9, which is equal to 7. So we got a positive value for prime of f. The function is increasing on the left side of -3. Now we can use the test value 0. So prime of f at 0 equals, so we get 0 squared minus 9, which is equal to 0 minus 9. So prime of f at 0 is equal to -9. So we got a negative value. That means the function is decreasing between -3 and 3. Now we can use the last test value, x equals 4. So prime of f at 4 equals 4 squared minus 9. So prime of f at 4 is equal to 16 minus 9, which is equal to 7. So prime of f is positive. That means the function is increasing on the right side of x equals 3. So now we can figure out whether the critical points are local maximum or minimum. Now at the critical number x equals -3, the function is increasing on the left side and decreasing on the right side. That means there is a local maximum at -320. So that's our first conclusion. The local maximum at -320. Now at the other critical point, now to the left side of x equals 3, the function is decreasing, but on the right side, the function is increasing. That means there is a local minimum at 3, -16. . So now we are done with the second part. Now we have to sketch the graph of this function. So for that, we should find the intercepts for the given function, because that will give us an accurate sketch of the graph. So let's start with the x-intercept. So for x-intercept, we'll sub in the function value as 0 and solve for x. Now this is a cubic equation and we cannot factor it using factor theorem. So for this we'll have to use technology to find the x-intercepts. So we can ignore the x-intercepts for this function. So now we can find the y-intercept. So for y-intercept, we'll sub in x as 0 and then solve for the function value. So f at 0 equals 1 over 3 times 0 cubed minus 9 times 0 and then plus 2. So the first two terms go away. So the y-intercept is just 2. So we can write it as an ordered pair as 0, comma 2. Now we can plot all of these points to sketch the function. So let's start with the critical points. So the first critical point we got is negative 320. So this is negative 3. So let's assume 20 is somewhere here. So the first critical point is here, negative 320. Now the other critical point we got is 3, negative 16. So 3 is here and negative 16 will be somewhere here. So the other critical point is here, the local minimum. Now we got the y-intercept at 2. So that's here. Now we can sketch the graph. Now as per our analysis, to the left side of x equals negative 3, the function is increasing. So we'll draw a curve that goes up from left to right towards the local maximum. Now between negative 3 and 3, the function is decreasing. So we'll draw a curve that passes through the y-intercept all the way down to the local minimum. And now on the right side of 3, the function is increasing. So we have to draw a curve that goes up from left to right. So this can be the sketch of our function. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to keep in mind the steps to solve this type of problem. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.